Okay, so hello everyone. I'm Balázs Šarenec. I'm a PhD student at the Faculty of Technical Science from the University of Novi Sad, and today I'm going to talk to you about improvements on refactoring engine in Faro. So the talk is titled "A New Architecture: Reconciling Refactorings and Transformations," and this is the work that I did together with Stéphane Ducasse and Nicolas Sanquitil. Louder. Okay. So first up, we're going to start with defining some terms so we can have similar vocabulary while going through the presentation. So what are transformations? Those are non-behavior preserving source code modifications, whereas refactorings are behavior preserving source code modifications. Next, we have preconditions. Those are checks that has to be met in order for us to execute the refactoring. Then we have atomic refactorings. Those are refactorings that are not composed on any other refactorings, and composed refactorings are consisted of other refactorings. Okay, so now try to imagine a world where we only have refactorings. So maybe it's fine in statically typed languages, but in dynamically typed languages, this does not work that well, because sometimes we want to override the method, and if we only have refactorings, it wouldn't allow us. When we create a method, it wouldn't allow us because we sometimes might override it. Yeah, so in those scenarios, we would like actually to do a transformation, so not check if there's an existing method. And if we have only transformations, on the other side, then we might break the system a lot. For example, if you use any dynamic language in Visual Studio and you rename a method with the existing name, your system has two the same methods and all the callers are the same. So we need both sides, actually. So we're going to look at two examples how we deal with this in Faro. So imagine trying to remove a method called private transform here that has 10 dead senders that are using it. Okay, so what we do actually is tell you that we are not sure. Do you want to do a transformation or a refactoring? Because it might be a method that you have in your library and there exists somewhere else. So you want to remove only specific ones. You might want to remove all of them, or you just want to see what are the senders because you were not aware that there was any senders of it. Yeah? So we try to give you all the information so you can choose exactly what you want to do. Another example is this is a code example. So when you are inlining a method, and if that method was overridden, we're going to give you a warning and say, okay, you're trying to override an inline method, and that you might, with that, break some stuff in your system. So are you sure you want to continue? So we are basically asking, we are basically saying, this is not guaranteed refactoring, but if you know what are you doing, you can proceed, or you want a transformation, so you can proceed anyway. Okay. So what is the relationship between transformations and refactorings? Gustavo de Souza Santos defined transformations and composite transformations, actually. So in Faro, we have two packages. One is for refactoring, other is for transformation. And the transformations and composite transformations are really nice, but they actually brought a lot of code duplication because they're the same refactoring transformation with same name and similar execution logic and preconditions and everything. So sometimes it's difficult to understand which one do you want to use and how. And what about preconditions? Currently, in Faro 11, transformations never check preconditions unless you explicitly tell them to do it. And this might be not ideal in some cases, and we'll see an example in a short while. So goals of this talk are like two-way. We have engineering and scientific goals. Engineering effort that we're trying to do is modernize the refactoring engine, so reduce code duplication, cleaner code, and produce more tests, because it's sometimes very hard to reason about preconditions and everything unless they are covered with tests and create some changes, because a lot of you are, and me as well, and everyone is depending on refactoring, and we don't want to do some non-behavior preserving refactorings. So next is SS refactoring. So there are a lot of preconditions that sometimes are incorrect, or they weren't covered with tests, so they weren't behaving as we intended them to. So we have to check a lot of preconditions and semantics. And there are also usability issues that are mostly related to user interaction, because we don't want to show up too much pop-ups because it annoys the people, so we try to optimize the user interaction to user experience. And for scientific work is we are trying to look at the relationship between transformations and refactorings, like how do they communicate, what's their relation, should they keep both of them or remove them, or what to do. And next is understanding composition issues. This is something that's ongoing and we start yet, so we're not sure exactly in which path we're going to go, but we have a lot of open issues. And our ultimate goal is to actually support you to create your own refactorings and create domain-specific refactorings and transformations, so you can have your custom workflow, and we can have custom refactorings that will be bundled with libraries or frameworks. Okay, so refactorings actually have a really nice basis underneath. They don't operate on the image itself, so when we do modifications and precondition checking, all of that is done on a model that's created model of a system that we create beforehand. We check preconditions, we do transformations on that model, and then when user is actually satisfied and he chooses what he wants to perform, we took those changes and performed them on the image. So we have this notion of a kind of atomic approach and transactional, but it's not really transactional atomic, but you are actually safe until when you press yes, then everything is performed. So let's now talk about preconditions. Do you think that transformations need preconditions based on definitions that? Yes, no? Okay, yes, great. Okay, so that's the correct answer. I'll show you an example in a little bit, but first I'll talk about different kind of preconditions, but because that's important to realize why do we actually need them in transformations. So last year on IWST, there was a paper published called Transformation-Based Refactorings that introduced different kinds of preconditions, and we have them here written. So we have applicability preconditions, and those preconditions check if it makes sense to actually perform a refactoring. Like if method should exist in order for us to remove it, right? For breaking change, it's checks that we do to ensure that you are not breaking your image, your system. Skipping ones are interesting because they check if a refactoring is a no-op. So those one checks, for example, when you rename a method and you don't change a name. So we can skip those. Yeah. And there are others because some of them are really complex and hard to reason about. So we are still cleaning them out. And my thinking is that they will be eventually categorized in the three categories above. So this is an example of applicability preconditions. When we want to add a method, we want to ensure that method is parsable and the class exists, because we don't want to create unparsable method that you can call and raise an exception. And also, breaking change precondition example is when you also want to add a method, we want to check that you don't, by mistake, override an existing method. So we will ask you, do you want to override or not? So yeah, those are examples about preconditions. And now let's talk about reuse, and this is connected with the preconditions story, because our thinking is that actually transformations need preconditions, and they need specifically applicability preconditions, because even though we are doing transformations and we don't guarantee to preserve any behavior, we should at least not create exceptions or open the debugger. So transformations have applicability preconditions, and then refactoring have breaking change preconditions. So what we did is to make refactorings a decorator of transformations. So transformations are the one that will check if it makes sense to do something, and that will actually perform the transformation. And refactoring decorates them and ensures them that you don't break the image. Okay? So and code example is like this. So for precondition checking, refactoring will first ask transformation, does it make sense to do it? The transformation will check applicability preconditions, and then refactoring itself will check breaking change preconditions. The transformation logic is then performed by transformation itself, so refactoring delegates execution to transformation. And then transformation actually does the transformation, which is, in this case, for add method, is to compile a method in a class. Okay, so this is a sum up on a slide. So we have another extra step that I didn't mention earlier, and that is that refactoring can do some additional cleanups before or after they're performed. For example, nice example is pull-up method, where if you pull up method that uses a variable, sometimes you want to pull up a variable as well. So they're connected. Okay, so the state of the situation is that we are actually in the process of migrating all the refactorings and transformations to this new architecture. And we started the process with few transformations and refactorings, and we like the results so far, and they allowed us to reduce and remove a lot of code duplication. Because, for example, add method transformation was used all over the system, but not explicitly. But a lot of refactorings were compiling methods on their own, and now we can use the transformations for that. Okay, so now we're going to speak more about engineering, and more specifically, the first thing is actually refactorings and transformations didn't have same API, and it was hard to use them, to mix them together. So what we did is to unify their hierarchy, so they're under same hierarchy now, and have same execution logic. So you can see on the left side that we had some different API, and now they use the same API, and they only override their own specific stuff like preconditions and transformation logic. Okay. So this allowed us so this cleaned the API, so it's better now, but it also allowed us to have some nice improvements of the code, like partial instantiation of refactoring, which is very important when we talk about user interaction, because we cannot create refactoring at once, but we need to gather a lot of data from the user and give it and check. And so basically need to have a nice interaction between the user and the refactorings to create them. And also we have moved more responsibilities to refactorings, which is also useful for user interaction. And we'll see some examples later. Next on engineering, we revisited preconditions. So there are some very hard to reason about preconditions. Some are wrong and obscure. Some are, so we used to add a lot of comments because we used to spend a lot of time, like hours, trying to figure out why some precondition does exist. It's usually because in refactorings, there are a lot of, and specifically in breaking changes, there are a lot of static analysis that we do to ensure that something is not breaking anything. So we actually added a lot of tests, so we cover all those cases, and now we understand them and we add comments, so if someone looks at it, he knows exactly why we do those checks. And also, we are trying to, everywhere in the system, split preconditions on breaking and applicability so we can easily use them and reuse them. Okay, next thing is there's a T in the system. I'm not sure if you noticed, or I think there exists in FAR 11 and in FAR 12 now. So with this, we're trying to tell you to differentiate refactorings from transformations. So if an action has T prefix, that's a transformation. So we don't guarantee that you won't break your system. For example, here you can see it in make abstract or in realize class. So next up is migration to Commander 2.0. So FAR has two command patterns implementations, and the whole system is migrating to the new implementations, and refactorings need to do it as well. Next up is UI. So let's talk about UI. UI in refactorings is, it was everywhere. So you could not miss it. And there was a fun game, I like to call it, where is this dialogue coming from? Okay. In every condition, yeah. So preconditions were like you didn't expect it, but they had a lot of dialogues popping up and like either gather input or raise warnings on say like, do you want to continue? We saw an example at the beginning. So what we are doing about it is that we introduced a new class, the middleman class that we call driver, that is actually responsible for for all the UI work. So now command actually invokes the driver, and driver will configure refactoring. It will gather the input and all the UI work. So this is the new architecture that we came up with. So the user invokes a command that will delegate execution to the driver. The driver will gather all the UI necessary information from the user and then invoke the refactoring. So the right part stayed the same. We changed the left part. Okay, so these are drivers and possibilities. The two ones that I haven't mentioned yet are displaying errors and warnings. So this is something that we are still working on. We don't we have a few implementations. We try to figure out which one is the best, and also display any other relevant information. So these are notifications or browsers, because when you have a refactoring, and for the example we had before, sometimes when you finish refactoring, you want to show the user senders of some method, for example, or implementers, because he wants to browse what happens afterwards. So those are some nice failing reports that we can show, so he can easily expect and fix any stuff that was necessary to fix afterwards. Okay, and warning and exceptions. So these are tricky because they're like implicit control flow, and it's very hard to deal with them because we have UI and exceptions and precondition checking. So the execution flow is all over the place. So we are still figuring out how to exactly deal with that. Okay, and the last part, I think, is about composition. So this was started very recently, and we are still exploring this space. So initially, as I said, Gustavo de Souza Santos started to define modular transformations. He created RB composite transformation, so you can easily create composite transformations. Refactorings didn't have composite, so we introduced them, and we are now playing with the semantics and try to use it so it fits better in the system. And it was very needed, and I'll show you a few examples. So this is RB composite refactoring. It basically consisted of multiple refactorings, and it has the same API and everything, but it enables us to, so besides creating composites, to create some custom precondition checking logic and custom transformation execution logic. So, for example, this is remove instance variables, and we can see how we can use composite refactoring for it. So we collect refactorings and put it in composite, and he will then execute it. And for execution logic, that's the interesting part right now. So we're trying to figure out what's the best way to do it. Should we check all the preconditions up front? Or like an example of composite, this is the default implementation, is to check preconditions, transform, precondition, transform, and so on. And another interesting one is skipping failed. So we are still playing with it, but it seems to be very useful when doing scripting, because we don't want to stop during a script, but we can maybe continue and then later give the user information. And yeah, the default option is to fail on the first one that fails, but sometimes it's useful to actually skip it and go ahead. Okay, okay, so this is a nice example of custom composite. So this is a question for you. We have foo unique and bar unique, and they don't have any other senders outside themselves. And you can see foo only returns 12, and bar has a reference to foo and adds 1 to it. Do you think it's safe to remove these two? Yes, together, yeah? Do you think it's possible to do it in Faro? No? Yeah. So actually, it's not, because remove method refactoring will check that you don't have any references. And if you remove 2 of them, it doesn't, so it checks one by one. So it will say, oh, bar has a reference, foo has a reference in bar, so you cannot remove it, even though we are removing them together. So point is that removing multiple methods together and removing one by one is not the same. So that's the real benefit of composite refactoring, because now we can have custom composition precondition checking logic, and we can say, okay, do these methods have any senders outside of themselves? Okay, so and then we can remove them. So this will be available in Faro in few days, I think. This is something I'm working on right now, actually. So, this composite work requires a lot of validation and case-by-case analysis, because there are a lot of refactorings and there are a lot of ways to combine them together. So we need to be very careful and not to think about all the possible scenarios where it can go wrong and where it can be good. Okay, and this is future work. So there's a large effort up front. We need to continue eliminating duplicate code between refactorings and transformations, and we want to leverage composition, so we can create nice composites. We want to migrate to Commander 2.0 and migrate user interaction to driver, and there's a lot of more work besides this, but these are like the biggest ones so far. And yeah, that's mostly it. So the summary is there are also many hidden improvements that we didn't talk about, because this is already too much, I think. Driver for the interactive application of refactorings. There are clear roles between transformations and refactorings. Like refactoring is now a decorator of transformation, and it ensures that everything will be behavior preserving at the end. And we have better separation of concerns there. So yeah, you can see the new architecture on the image. And yeah, there's a lot of work ahead, but we cleared it. So we put a lot of work in, and it's much more clear and easy to work with. So yeah, thank you. That's it. Okay. Any questions? Yes.
You have preconditions, but do you have both conditions? Just both check results?
No, currently we don't have them. Yeah, we didn't. So.
Test. So you have unit tests. So you know that usually the refactoring should go away.
Yes, with that. So I don't think they were present in the system. I know there was a PhD who investigated that, but I'm not sure that it was ever implemented or used. And yeah. Any?
Is there intent to go to ring for the meta model?
Can you?
I will reply.
Okay.
So the question is there an idea to go to ring for the meta model? Right now, not. No, we are also fixing the fact that the precondition should not use the Faro meta model directly, but should use the refactoring browser model and those kinds of things. So we don't want to introduce noise. We are stabilizing what we have, making sure that we improve the API of RB class, RB methods, and things like that. And in the future, maybe we want to get rid of this meta model. We want to get rid of ring and just use the one of Faro if we succeed not to install the classes in the system, because we could use class as the representation on something that is not executed right now. So that would be the trick, in fact. Okay. Thanks a lot.